Alright, so for number 36b, we're going to again state the amplitude, period, and phase shift, vertical translation of the sinusoid, and then also we are going to sketch the graph marking the x and y axes appropriately. When it says marking the x and y axes appropriately, this is labeling the scale. So mainly the x-axis scale is the most important part when you are completing the graph of a sinusoid function. So first off, we're going to start talking about the amplitude. The amplitude in this case is 5. Again, we take that directly from the a value. Okay. The period we are going to determine with our equation. Period is equal to 2 pi over b. Okay, so the b value in this case is pi. So that's why we've substituted a pi here, so therefore period is 2. Our phase shift is going to be left 1 unit. Since it's plus, we know it's opposite, and it's phase shift 1 unit left. So in this case, we are then going to want to go ahead and start drawing this graph. Since you are counting by 1, 2, 3, 4, it's going to be pretty easy just to go ahead and label 1, 2, 3, 4, etc. Okay? Now just know that the 1, 2, 3, 4 is not necessarily what you're going to where you're going to label your critical points. So some of you may have a tendency to go from 1 to 2, but notice that it's going halfway between 1 and 2 because you still have to determine how much you count by. So you're still going to take this 2 and you're going to determine what you count by dividing by the 4 equal parts of a sinusoid function, which gives you 1/2. So that means you know that you are going to have to increase every 1/2, and at every half you're going to have a different critical point. So in this case, you're going to start at the phase shift of 1. This is a negative cosine function, so you should know that a negative cosine function starts at the bottom, goes up, and comes back down. So again, it's going to look, and here are your 4 critical points at these 4 spots. So here's your first, second, third, fourth, and then at the end. Okay? So you're going to increase by half, which will put another critical point between 1 and 2 at 1.5. Then increase another half to 2, another half to 2.5, and a final half to 3. So again, graphing each of those critical points along the curve. Okay, so you're going to go up, increase up, and then come back down. And then of course you can go ahead and continue that cycle both to the left and right if needed. Counting by the same, and I can't draw it very well, so I'm just going to leave it off. You're also going to want to label these critical points. So 1, 5, and again the 5 comes from your amplitude. So this is not shifted up or down with your value of d. So therefore, you know that your midline is going to be along the x-axis, and you're going to go 5 up and 5 down. So that's going to determine your top and bottom of the function. So 1, 5, and then 1.50, and then 2, 5, and then 2.50, and then finally 3, -5. Oops, and I just realized I should put a -5 here as well. So this is what your graph should look like. You really just need the coordinates along that first phase of the function. The outside phases, yes, they're important, but these are the most critical parts of the entire function. And finally, 36c. Again, we're going to state the amplitude, period, phase shift, vertical translation of the sinusoid relative to the basic function f of x equals sine x or f of x equals cos x. Sketch the graph marking the x and y axes appropriately. Again, marking the x and y axes appropriately simply means making sure that you label this by the correct increments. Okay, we're going to talk about how we do that. First off, let's look at the amplitude. Notice that this is different from this. Because this 4 needs to be sitting outside the parentheses. So you actually need to factor out a 4. And when you do that, that becomes pi over 4. And we are actually missing a parenthesis here, so I'm just going to add in a parenthesis. Okay, so that will close that outside parenthesis for sine. So again, your amplitude is 5. So this gives you pi over 4 4 is the b value. So again, period equals 2 pi over 4. So that simplifies to pi over 2. That's your period, pi over 2. Pi over 4 is a shift. Pi over 4 right. So we're going to shift that pi over 4 right. And then it's a vertical translation down 2. Alright, so Again, we are going to go ahead and determine what we're going to count by on our graph. So we're going to take our period, which is pi over 2. Here's pi over 2, and we're going to divide it by 4. When I do that, that's really like multiplying by 1/4. So therefore, I'm going to count by pi over 8. That can't be simplified. Now, if you notice on this graph, they're just basically counting by pi over 4, pi over 2, 3 pi over 4. Again, you could restart this, and really you can put in whatever you want to put in here along. So here is pi over 8. Then you go 2 pi over 8 is really pi over 4. Then this could be 3 pi over 8. Then 4 pi over 8 is really pi over 2. And then you could keep going in those increments. Okay, that's really not important to actually put those little increments in. It just really helps when you are determining where to put those critical points on your graph. So really you should be counting by those smaller increments of pi over 8 instead of just counting by pi over 4s. Okay? So then again, this is a sine function. So you know that it's going to look, here's your midline, you're going to have your midline, and then it's going to start, it's going to go up and come back down, and then back up to the midline. So it's going to look like that. This is a phase shift pi over 4, and then it's vertically translated down 2, so your midline becomes -2. Since your amplitude is 5, you count up 5 and you count down 5, and that's how you get the top and bottom of the function. So now I'm going to start it at pi over 4 on the midline because I know my sine function starts on the midline, and I start at my phase shift of pi over 4. I then go up to my first increment of pi over 8, down to my next increment of pi over 8, down further to my next increment of pi over 8, and then finally back up. Okay? So you're then going to connect those dots. You'd also want to label what these points were. So 3 pi over 8, comma 3. And this is really mostly important for when you're doing word problems, but it's also good to just go ahead and get into the habit. The other way you could have done it is identify that this is a vertical translation down 2, by using your phase shift of pi over 4 right and your dilation or your amplitude of 5. And your b value, I guess it's more your b value. So for each of these, you could have applied first off, you could have added the pi over 4 plus pi over 2, and then multiply by 1/2, and you get 3 pi over 8. Again, you always start at that phase shift. That phase shift is always the point you start at. Okay. From there, though, you're going to take the pi over 4, you're going to add your period divided by 2, again here and here. So you could also get those points by simply using your translations.